This one right here. 40 times a half, that'd be 20. Did I get too many pins there? I did too many pins, sorry. But look at how much damn fence I'm using here. Look at how much fence is from here to here. 40, right? 40, another 40, another. So I need 4 40s. 1, 2, 3, 4. I need 4 40s, right? That's 160 feet of fence already, just to get these. And then what about across the top here? Whatever, it's like half a foot, half a foot, half a foot, 1.5, and then down here, 1.5. So that'd be 3 feet. So how much is that? How much fence is that? 40, 40, 40, 40. So 4 40s, 160. Plus the 3 here. That's 163 feet of fence is how much I need to build it like this, right? How many feet of fence would I need here? 10, 20, 30, 40. 40, right? And then 42, 44, 46, 48, 50, 52. So only 52 feet of fence, right? Regardless of it's chain link or wood. What I'm getting at is the different shapes, the different designs are going to be a different amount of fence. And different amount of fence means different cost, yes? We have an added element into the problem, which is that we've got 2 types of fence. So it definitely matters how we build it. So if I'm going to go out there and build this for somebody, right? Like let's say I'm the person who's getting hired to do this. What I want to do is find the dimensions that will minimize my cost, right? That way I can make the most money off the farmer, right? I charge him a certain amount, but if I just go build it all haphazardly however I want, then I might spend more than I actually needed to spend. So the question for this problem, the question is, find dimensions which minimize cost. Then find the minimum cost. Okay, so optimization here. I hope you understand the problem at this point. We're trying to minimize the cost. Yes? The 2 sections prior to this have been about finding the maximums and minimums, right? Local max, local min, absolute max, absolute min. So we already have in our toolbox ways of finding highest and lowest points on graphs, right? Here we just need to figure out what is the function we're trying to find the minimum of. What is the function? What are we trying to find the minimum of here? What function are we trying to minimize? The cost. The cost function, right? We would like to know how much this thing's going to cost and then find its lowest value. So we want to start working on the solution here. We're saying we want to minimize cost, right? We want to minimize cost. That's kind of in the problem. It's already told. You already told that, right? So let's find the cost. What is the cost function? So what is this going to cost us? Well, the problem is we don't know what the dimensions are, do we? We don't know. So this is where we start making things up, all right? But we're not just going to start plugging in values like I was, like 10 and 5 and 20. What I'm going to do is I'm just going to say, hey, look, let's just call the distance from here to here. Let's just call that x, all right? And let's call the distance from here to here, let's call that y. Agreed? That makes sense? All right, so let's try and figure out how much this is going to cost us. Let's start with the blue fence. I'm going to have to pay $20 per foot, yes? How long is this side? X feet, right? So this side right here is going to cost me how much? From here to here? 20x, isn't it? Agreed? So I know that my cost right now is 20x. Now, is that the only part? What about from here to here? What about from here to here? That's also another 20x, isn't it? Because if that's x, that's also x, right? So that's 20x. We're adding, though, not multiplying. So another 20x. You'll see that? Now, is that the only blue fence I have? No, I have all of this, right? This, the whole thing across. How much fence is this? From here to here? 3y, right? This is y, this is y, this is y. So that's 3 times y, right? But That's how long it is. How much does it cost me per foot here? 20. So watch me how I write this. Plus 20 times 3y. Maybe what I'll do is I'll draw some little arrows. This 20 plus this 20x is coming from there. This 20x is coming from here. And then this 20 times 3y is coming from there, there, there. Does that make sense? Are we done with blue fence? We got the top side, right? Which is identical to this one, isn't it? It's another 3y, but they're $20 each. So plus 20 times 3y.
That's for the top section.
That's the top section right here. Okay? Are we done with our cost? Nope, we've got one other additional cost, don't we? That's that red fence. Right there and right there. How long are they? From here to here, what's that distance? X, isn't it? That's X. That's X. How much does it cost for me to build that little section? 35. So this is 35x and that's 35x, right? So I want to add to this. I'm going to have to do it here so it stays on camera. Plus 35x plus 35x. And those two come from there. I know this looks like a spaghetti factory now, but does this kind of make sense what I'm doing? I'm trying to generalize. I don't know how big I'm building this, and I don't know how big I'm building this, but I know if I set this distance to be x and this one to be y, then that's how much it's going to cost me. Now, someone would have to tell me what x and y are, but let's clean this up. This is c equals, now how many x's do I have here? 20x, 20x, and that's it, right? Oh, wait, no, sorry, I forgot about these now. So 20, 20, 35, and 35, so that's 70, right? 89, 110. It's 110 x's plus how many y's do I have? That's 60y and 60y, right? 120y. Okay, my cost is 110 times x plus 120 times y.
Dollars, yeah, dollars.
It'll be in dollars at the very end, yes. Yes?
I have a question towards the 20 times 3y actually.
What about it? Where'd it come from?
Basically, yeah.
Okay, so from here to here is y, right?
Right.
So let's just say that that was 2. Then this would be 2, 2, 2, that would be 6, wouldn't it?
Yes.
If this was 4, then that would be 4, 4, 4, that would be 12, wouldn't it? So you're doing 3 times whatever this was. So if this is y, 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 that's 3y. But it's blue fence, so it costs me $20 per foot. So it's $20 times 3 times y, which is the length of the side.
Right.
Okay? But then there's another one on top. So that's that one.
If we did 60 times or 60y, it would have been the same thing as 120y, right? At the end.
If we would have done 60...
If you didn't split it up
Yeah.
into 3 sections,
It would have been 120. We can't do
Ye-
that.
Wait, if we would have done... Say it again. If we would have done not into 3
Like
sections...
instead of doing 20 times 3y,
Uh-huh.
we could have just done 60y plus 60y on top and then added those on the bottom.
60...
Basically,
Yes,
you
yes, you could have, yes. Uh-huh,
Okay.
absolutely. Yep, 16, 60, yep. Okay, I've got 5 minutes. Here's our cost function, right? This is our cost function? Here's the problem with our cost function right now. Every function we've dealt with so far in this class has been like f of x equals, and it would just have x in it, right? Like x squared, x to the fourth, whatever it is. Look at this function right here, our cost function, has x and y in it, right? 2 different variables. So what I need to do right now is somehow make these all x's or all y's. And the way I'm going to do it is to use the one piece of information we have not taken into account yet, and that's this. Okay? Look at this right here. What does that tell me? My total area, right, of the total thing has to be 60 square feet. So what is the area of this shape? What would it be? It's x times this side, right? This side's not y. This side is 3y. So do you all agree right now that x times 3y must be 60? Do you all agree with that? This is a separate thought here. The area is 60, but the area according to that picture is x times 3y. Yeah? Now watch what I do. Y equals 20 over x. What did I do here? I solved for y, didn't I? I divided both sides by 3, which gave me 20. Then I divided by both sides by x, which put the 20 over the x here. Y'all see that? So what I've done is I've found a new expression for y, right? Y is 20 over x. So if I come back over here to my cost function, can't I write my cost function like this? Cost is equal to 110x plus 20 over x. Yeah? No, not, sorry, 20. 110x plus, I forgot to put 120. 120 times 20 over x. See, that's 20 over x is y, isn't it?
Yes.
Y is 20 over x. Has to be. In order to have 60 square feet, that's what has to happen. One more thing. Pardon? 2,400? Yeah, I'm missing 0 here. Thank you. All I did there was multiply 20 times 120. And that's on the top, so 2,400. Okay, I've got 2 minutes. As you can see, these problems are going to require some thinking, right? Okay. So here's where we are. Our cost is now a function of x. Right? That is our cost function. What we would like to know is where that has a minimum, right? Which means, what do you need to do with it? Set what equal to 0? You have to take its derivative, right? Then you have to set that derivative equal to 0. Right? Once you do that, what do you do with those answers? Plug them into the original. Okay, so do we have a closed interval here? No. We did not have a closed interval here. We were never given a restriction on x, were we? No. So you have to do this using the original method, which was number line, critical numbers, test points. Just keep this in mind. X can't be negative, right? Because that's a negative fence. I'm going to offer this as a bonus question. It'll be worth 10 points added to the last exam. Has to be turned in next class. You have to go figure out find the local maximums and minimums of that function. Right? And then, after you do that, you need to answer the question. Because the question was, find the dimensions of the actual enclosure.
So what's homework tonight? Is it just multiple?
The homework, do the homework for 12, was it 12? Yeah, 12.5, which is the absolute maximum minimum. There's just a couple of problems in there.
And then
Yeah.
and this is the bonus